Next generation is the Vortex rotary files with the new M-wire technology. This was produced to create a new super elastic wire for optimum rotary benefits for the greater resistance to cyclic fatigue separation, increased flexibility, and an increase in the efficiency of any previously manufactured profile instruments. This is a cross-section of the Vortex instruments where you can see at the tip end, we have a slight convex triangular configuration. But again, it's a pinpoint contact for efficient cutting. As we move up the shaft of the blade on the right, you see now we assume a more triangular configuration, a greater bulk of metal as the file gets larger towards the shaft end. And again, a pinpoint contact. Very efficient, very nice cutting instrument. Which now leads us into the topic that we will spend the most of the time on today, the Vortex Blue rotary instruments. The Vortex Blue design characteristics, one that I really like is the 11 millimeter handle versus the 13 millimeter. I know it's only 2 millimeters difference, but it makes a tremendous difference in the mouth, especially in maxillary and mandibular molars. So access is much better with this 11 millimeter handle. It has a safe-ended tip with active cutting blades, and it has variable helical angles, the angle of which the cutting blade actually comes off the center axis of the file. And it comes in 04 and 06 tapers, which we take advantage of in the variable tip, variable taper technique. And what also I like is the adaptability of the file to any canal, because it comes in 15 through a 50. And I can't emphasize enough the value of the 15 and 20 04 tapered smaller instruments in very curved, very constricted canal spaces, and how they can be applied very nicely to the MB2 instrumentation. The Vortex Blue has the same torque settings, speed, sizes, and technique basically as the original Vortex files. And here you can see the Vortex Blue as it compares to the twisted and the endosequence file in helical angles. And you can see the twisted file has a lot of flutes or spirals. You can see it has an increased helical angle, again, the angle of which that cutting blade comes off the center axis of the file. The endosequence has a decreased helical angle with less flutes. And the Vortex Blue file, you see a higher helical angle at the tip, more flutes, adding to more flexibility, with a lower helical angle in the mid file and coronal section of the file, adding to more efficiency, and again, pinpoint contact between the actual file and the dentinal wall. Also, the Vortex Blue goes through a variety of processes, manufacturing process, to actually decrease or reduce the shape memory of the wire. And this is a tremendous advantage, and you can see this in front of you. Standard superelastic nickel titanium always has a tendency to want to straighten, okay, which is fine. However, the Vortex Blue, you can see, has a slight curvature to it. We take advantage of that. It helps us for insertion purposes, especially in the molar areas, but also it conforms more to the canal walls. So I very much like the feel of this reduced shape memory that we have in the Vortex Blue. And you can see here in this micro CT scan that the canal on the right was instrumented with the Vortex Blue file, the one on the left with a standard nickel titanium instrument, and the blue instrumented canal, you can see there's better adaptation to the canal walls because of this reduced memory in the Vortex Blue instrument. So it's extremely helpful. And actually, when I'm actually using this file, this reduced memory gives me somewhat what I would call a soft feel, which increases the tactile sensitivity of this instrument in my hands. I can actually feel the file engaging the curves and going around the curvatures in the canals. So to me, that any type of field advantages I can gain is tremendous. It's an absolute tremendous advantage in instrumentation and safe instrumentation.